Hello, everyone. Today we are going to discuss chapter 20 from the Mastering Shiny book. And this chapter is about using packages, converting your Shiny apps to packages so that you can use your app in a package workflow when you're developing it, and also providing that package for production. To create packages, you should put all your R code in a directory called R. You should write a function that starts your app. That is, it calls the Shiny app. Uh, so if I switch to our studio and show you the general structure of a Shiny app, when we create UI and server, after that we use this function Shiny app, where we provide the UI and server functions. And this is what this is what runs the app. So we need to wrap this inside a function so that we basically run that function within the package. And the package also requires a description file that should be in the root directory of your app, so the main directory of your app. And in this chapter, they don't really create a full-fledged package that can also pass the RCMD check, which is one of the requirements to create a package. But they talk about that and the benefits of doing that. So we first obviously load the Shiny package, and then we are going to convert an existing app to a package. So the way that works is that everything that we have within our app.r file that should be wrapped in a function which we can name as anything we want. In this example, they name it as my app, and the UI part, the server part, and the Shiny app function all are inside this my app function. So we can create a package and different components of the package using different functions from the use this package. For example, to create the description file, we can use the use description function from use this. And if we are not already inside an RStudio project, we can use RStudio. That's also a function from use this package. And while we are developing the app, we can use DevTools, load all. The advantage of doing this is that it will load all the files in the R folder that contains our code. So we don't have to source any code that is outside of app.r, for example, functions or reading data or something, anything that we generally put in a global.r file or something. All of that can be put inside the R folder within different R files, and we can load all of them when we run the DevTools load all function. So here's an example of a single file Shiny app. So I'm going to switch to our studio and show how that app works, what it looks like. So currently this app is named in our script called 20 underscore 1 underscore 1. There's 20.1.1 section in the chapter, and it uses a CSV file called as birthstones. And this is what the app looks like. We have a title and we have a navigation bar. It contains three tabs: pick a month, feedback, and birthstone. So here in the first tab, we can pick a month, for example, February. We go to the feedback, it says you could do better. And within birthstone tab, it says the birthstone for February is amethyst. And if I change this to October, then I get better feedback, and the birthstone is opal. So this is how the app works. It's a very simple app, and we can convert this into a package. So this app uses modules, which was the topic of discussion in the previous 2 weeks. And if you look at it, here is the first module that we're using. It actually uses just um, two modules here. So the first one is month feedback UI. So this is for the second tab in our app, where the UI contains only a text output that will contain the feedback. The server part of this module first checks if the input month is reactive or not. It should be reactive, so it will stop if it's not. And then it will create a text output using render text. It checks if month is October, then it says you picked a great month, otherwise it says you could do better. So this is a simple module that takes in the month as the input for the module server and then gives you feedback. That feedback is shown in a text output. The second uh, module here is the birthstone module, and the birthstone module depends on the birthstones.csv dataset. So here's the dataset. If I open that here in our studio, we see it says comma separated value file. The two columns are month and the stone. So for each month, we have a corresponding stone value. So what this module does is in the UI, it creates a paragraph that's coming from the HTML tools or the Shiny paragraph tag function. And it uses two text outputs. And it is specified here that they are inline. So they all, the text output would appear inline in this paragraph text. So we have the birthstone for the first text output is based on months, and then it says is. The second text output is based on the stone. So month and stone are two text outputs, and we can see how that work by looking at the birthstone server module. Birthstone server module also takes the month as an input, similar to the month feedback server module, and checks if the month is reactive. Then within module server of the function, it will first create a reactive expression where it takes the dataset stones, which we have read here, and then it checks if the month is equal to the month that we have provided as an input to this module server. So if it is equal to that, based on that, it will grab the corresponding stone, and that will be a reactive value, which we name as stone. Then the first output, the month output, is used here for our user interface, is rendering a text that will contain the month, which is again the input for the module server. And the second output is stone, and this is what we have created as a reactive expression above, and that's then provided to render text. So whatever month and the stone are selected, they will be wrapped in a paragraph text for the UI part. Then here is the main part of the app. We have months. These are all the 12 months in a year. And we have a navbar page from Shiny. This is one of the functions to create a page. Instead of fluid page, we're using navbar page. We provide a title which says sample app. And then within the tab panel, we provide pick a month. This is the first tab panel. And within that, we have a select input where you can select a month. And these choices here for the select input come from the months vector here. The second tab panel will contain feedback. This is where we have the feedback UI, and the third tab panel is about birthstone, where we get the birthstone outputs, the two text outputs that are created here. So based on that, in the UI, in the server, we then use our module servers, and we provide the tab 1, and we provide the month as a reactive input. Similarly, for birthstone server, we name it as this is the tab 2, so the input ID here is tab 2, and the reactive expression that we provide here is again the month, because both of these require month as the second argument. And so as I showed before, let me show that again. That's how the app works. Actually, I think because I'm sharing my our studio screen only. You may have not seen the app before, so I'm gonna switch to run in viewer pane and run it again. And this time you should be able to see the app. So we have pick a month, feedback, and birthstone. And if I change the month here, look at feedback, we get you could do better. And we see the birthstone for March is aquamarine. If I change that to October, then you see you picked a great month, and the birthstone for October is opal. So this is a simple app which has two modules, and let's see how we can uh, convert this to a package-based app. Switching back to the chapter, uh, the first step we need to do is create an R folder in our root directory of the app, and then create separate files, R scripts for each of the modules. So if we go back and I go to the Files tab in our studio, go to the main directory, and here we have, remember this original single file app that was not based on a package folder, which will be clear in a moment. Going back to the root of the app project, I see here that we have the R folder. So this is based on the instructions in the birthstone.r and monthfeedback.r. We have already seen the code for these two modules, so we have separated them into two separate files. The next step is to put the app.r, the remaining part of the main part of the app in app.r file, which we are also putting inside the R folder. And so the app.r will contain the same code as before. The only difference here is if you look at the instructions here, we have library shiny, stones are read from birthstones as CSV as before, and everything else is the same as before. But as will be clear later, we need to convert or wrap this code for the app.r inside a function, which in this case we call as month app, because then we can run month app for development as well as. So that's exactly what we do here. We have all the code as before. There's no difference there, but we wrap it inside a function. We name it as month app, and the function arguments are the three dots, which refer to additional options that we may want to provide to the shiny app function. And the shiny app function can contain like information about the port number on which we want to run the app and so on. So let's take a quick look at app function. So here we see UI and server are the first two arguments. There's also on start, options, UI pattern, and enable bookmarking. So you are familiar with bookmarking now because we have discussed that previously in our discussion. Uh, let's now switch back to the chapter. Uh, as an and also get rid of the birthstones.csv. And since we are in a package structure, we can actually use data function from use this package that will take in the stones file in the memory and do stones.rda. So here, if I refresh, restart my R session, and I'm only going to run this part. Right now it's in the current working directory, and that's true because if I go to files and go to the root of my directory, we don't see a birthstone or CSV here, but we do know that it's inside a folder. So if I open the dev folder, and by the way, the dev folder is something that the R will ignore. Uh, the package development infrastructure would ignore because uh, anything that's in there, uh, we are using it only for the development purpose. We don't want it to be the main part of our package. So that's why, for the purpose of example, I put the data and the original single file app inside dev, which is not discussed in the chapter. So if I run this, now the stones data is ready, and I can show you that here in the environment tab. The stones data looks like this, and now it's in memory. If I now use this use data stones, remember that I here. So I already have a data folder here, as you can see, and I have the stones.rda. Let me delete it to show you that it will create this data folder for us that will contain. Uh, so now we have the data folder again, and we can have the stones.rda, which is the best format that R uses. And so whenever we do DevTools load all, it will load all the also load our data for us. So we don't have to manually load it like this. And that's why I commented it out. So what's the benefit of doing this? Why do we do all of this work? The benefit is that if we run DevTools load all, as I said, it will automatically load all the files and the data sets, which are in R and data folders, respectively. We can rerun the app with simply using my app function or whatever you named it. So if I show you that here, I'm gonna do session restart R, and now I can do DevTools load all. Load everything inside our folder and as well as the data folder. And now I can run my month app. And it runs as before. So choosing October should give us more positive feedback, and the opal as the birthstone, so it's working correctly. And so any change that we can make here in app.r or in any of our R files in the R folder. And we can also add additional modules here and add them to our app.r file. So that's the advantage of using a package-based workflow. Because we use this a lot for package development, one of the recommendations here is to put this code in your R profile, which you can create using use this added R profile. It will create a project-based RStudio project-based R profile file .r profile, and it will be in the root of the directory, and it should contain this code that you should copy and paste, and then you don't have to say use this colon because use this package will be loaded for you, so you can directly use the package functions. How do we share this app with anyone who is familiar with using R but is not familiar, or sorry, not has your code? You can provide your package code to them as package. Then they can run that at their end for the purpose of development or for just using the app. If you do not want to, then this would be based on confidential internal company data. So if your team members are familiar with R, you can just provide them GitHub and other options, and they can use it inside our studio. There are some optional extra steps if you want to put this app into production and deploy this app on Shiny apps or um, services like AWS or Google Cloud Run to actually have this package working as expected. For that, we need to do this. We need to take, say, load all. And so now we'll need an app.r that tells the deployment server how to run the app. And the easiest way is to load it with package load. App.r file should be, I think, outside of the R folder. So in our previous workflow, we have app.r inside the R folder, but if you generate the app.r file and put that in the root of your directory, where you say package load, load all, and with a dot, because that is the root of your directory, and then you can directly use your app. And for this, you need to use package shiny and use package load. By the way, if you are adding what to use in your app, in your app code, you have to do this use package so that it's listed in your description file. Let me show you the description file here. So in this case, is room, VROOM development. I didn't have to in the depends or in the in the imports. That's argument of the description file. So it is working for me locally. But if I want this package to pass the RCMB check, then I need to provide name inside the description under either import that we can do using function. So this is what is discussed here. RCMB check is difficult to pass, and in our studio, in DevTools check function, what you need to do is you need to get rid of the library or the require calls for your function, and you should have your packages listed under description. And so you either use the functions from the package using the package name and colon function name, or for each say import from and the package name and the function name, which is recommended compared to using just import. But for the Shiny package, because we use a lot of functions from Shiny, it's recommended that we use add import Shiny. So these are additional steps that we need to take in from this chapter if we really want this package to be deployed. Sorry, the app to be deployed. If we have confidential data or don't want to use like use proprietary license. This is also from the use this package. App.r should be added to building nor with app.r. And this way, although app.r, we won't have any problems to pass our CMB check. If you're using data like we were doing in this example, we can either put the data inside the data folder using the use_data function as discussed before, or we can put that in inst folder and within that in the ext data folder. You can also put your raw and then load it with read.csv. So there are many different options for using external data. We can also use the package. This requires that your package is available somewhere that your deployment machine can install from. For public works, this means that your package is either on CRAN or it is on GitHub, meaning using a tool like RStudio Package Manager or Drat. So in that case, if your package has this function, my app, and your package is also named as my app. You can then directly use it as shown here. So in summary, in this chapter, we've discussed an existing app to a package-based app, and we've discussed additional steps that we need to take in, and we want our app to work as a package. This is everything is in context of using Shiny app. In the next week, we are going to discuss testing for Shiny app. Thank you.